Hey, it's me again. Welcome back. I had a good time in the previous video just blasting around on a motorcycle. And since it's fairly early in the game still, at least for me, so I figure I'll keep doing that and go look up points of interest on the map while I do so. You know, I have myself a nice virtual ride here while I yammer about today's topic, faster than light travel. Before I get too far into this, if you haven't seen the previous videos, please feel free to go back and watch them. Drop a like if they're not terrible. Subscribe if you can, so you can get notifications. You know, I do more stuff like this. To start with, I'll begin by defining the speed of light. It's been measured roughly as 290,792,000 and change-ish meters per second. Let me do some math and translate that out to metric. I'm going to dig out my calculator here and check on the map while I wait for traffic. Anyway, this ridiculous number of meters per second translates to about 186,000 miles per second, or 300,000 kilometers per second. Just to be easier to say, I will round up and call it 300 million meters per second. I'm going to dive through these bushes and cross the field here. Where was I? The speed of light is really fast. For example, the Saturn V rocket we used to put men on the moon achieved a maximum speed of about 17,000 miles per hour, or 28,000 kilometers per hour if you're inclined to think in metric. To convert the earlier speed of 186,000 miles per second to miles per hour would make 670 million miles per hour. That's a lot of miles per hour. If you managed to continually accelerate at the Saturn V's maximum speed, it would take 39,400 hours of continuous acceleration to reach light speed. Convert hours to years, and that's 4.5 years of constant 17,000 mile per hour acceleration. And we all know there's no way we can physically do that because fuel. Like, in order to accelerate longer, you have to carry more fuel, but more fuel means more weight, so you have to make more power, which requires more fuel, which means more weight. It's a vicious cycle. Actually trying to get to relativistic speeds is generally thought to be impossible. But that's a different discussion. For now, I'd just like to illustrate, so far as we know, why it's impossible to reach the speed of light. It's an uphill battle. I'm sure humanity will figure it out. I dare say the survival of the species may depend on it. Let's see if I can squeeze between these rocks here. Nope, the game won't let me. Anyway, another real-world example would be the Voyager space probes. Voyager 1 was launched in September of 1977. It's still running and it's still transmitting and receiving signals, doing science stuff even though it has long left the solar system. It's been running for going on 43 years now, and is the most distant man-made object from Earth, about 13.8 billion miles from us. So far, in fact, it takes around 20 hours for radio signals to go one way from here to there. Having all this time to accelerate, it's still traveling at 38,000 miles per hour. Voyager 2, launched 16 days later, is still running too. They're getting way out there. Oh, this is a military base. They're in bed with the cartel, but they're much better equipped and coordinated. I don't want to mess with them yet. I think I'll pop the drone up here a little bit, do some more scouting, and then we can skedaddle. Back to the Voyager 1's impressive 38,000 miles per hour. There's only, that 38,000 miles per hour is only 0.00005% of light speed. It's taken the Voyager 1 probe more than 40 years to travel 20 light hours. Not like years, just hours.
Sniper at the tower.
Yeah, there's a lot of bad guys here. Let's get out while we still can. Oops, I missed one on the road down there. There he is. Alright, let's get back to the bike. Now, speaking of space travel, We don't strictly need to achieve light speed, or faster than light speed, in order to open up the whole galaxy to us. I get down this mountain now. Without falling in the water.
Alright, we're all clear.
Baby. Where's my motorcycle? Ah, here's my bike. Alright. Hopefully this water isn't too deep and I can just ride out. As I was saying, humanity doesn't need to get all the way up to the speed of light. If we could even reach only 25% of light speed, which is still 46,500 miles per second, that would open up the whole galaxy to us. For example, the nearest star system to our home star is the Alpha Centauri cluster. It's roughly 4.4 light years away, which totals 406,410,000 miles. The Alpha Centauri star system is actually 3 stars. 2 called simply A and B orbit each other as a binary pair. They're in close proximity to each other. The third is referred to as Proxima Centauri and orbits the other 2 stars together. And it itself is a small low-mass star. It's hardly more than one of the gas giants that are in the depths of our own solar system. This star cluster has 1 confirmed planet, possibly a second. And that's just what we can see from here. If we got closer, who knows what we would find. At 25% of light speed, we could get a probe from Earth to Alpha Centauri in 17.5 years or so. I know that sounds like a long time, but it's fast enough that the people who helped build it and launch it would be able to see it arrive at its destination. Sure, it would take another 4.5 years for the information from the radio signals to arrive back here, back at Earth. But oh, the things those signals would tell us. Just, imagine what we would learn if we had a probe presumably full of advanced scientific instruments in a different solar system, bathed in the light of different stars, casting shadows on different planets. Who knows what we could learn? The possibilities are baffling, literally endless, because it is the unknown. There's so much traffic here. Which is sometimes the fun part about riding a bike. We'll pass this car. There's another car. Hopefully there's somebody coming. I gotta dodge him. Not run off the cliff. Alright, let me reorient here. Where was I? Yes, it's slow and cumbersome, but it's tolerable, and we could do 4.5 years. We could send probes there. We could communicate with them, learn from them. And if we did, oh, the things we could learn. The possibilities are limitless. 17 years is short enough of a time span that, say, we found a nice juicy planet out there, that we could send people there. Yes, I seriously mean to colonize another solar system. Selected, trained adults could be ready for flight. Say, selected at 18, trained and launched at 25, and then arrive at age 42, for argument's sake, ignoring the difficulty of 17 continuous years of spaceflight and how that would be done logistically or what it would affect the crew physically. But if they arrived at age 42, they'd still be able-bodied adults. They'd still be colonists, spreading humanity among the stars. How cool would that be? I mean, how about them apples? Yeah, I'm gonna take a shortcut off the road here. And we'll see if... Oh, look at those guys. I know I said I didn't want to fight the local military, but I said they were in bed with the cartel, and here it looks like they're gonna rough up some civilians. I want to do something about that.
We have a third target. Marking the hostile. He's close to some locals.
I don't see anybody else. I'm gonna use the drone here just to make sure. I'm not going to bite off more than I can chew. Alright, I'm going to call it good.
Makes 5.
Yeah, that guy's way over there. I'm not worried about him. Alright. I'm going to call on my NPCs for help a little bit.
Got it.
That guy.
Let me
That
find a good
guy.
position.
Copy
That guy.
Moving.
Target acquired.
Oh look,
Ready.
there's
Slow
another one
shot.
hiding behind the tree. Alright. And
Tango with multiple civilians around.
blast them.
Engaging tangos.
Target down.
Don't get away.
Bird's nest.
There, got him. Alright. Alright, check the map again. Get back on the bike and then check the map. Let's boogie before someone comes looking for those guys. Anyway, for now, that's still a fantasy of going to Alpha
Go ahead
Centauri,
without.
a daydream. Because we can't get going nearly that fast, and let me explain why. The first major problem traveling at near the speed of light imposes is the relativistic effects. Like I hinted at earlier, it would cause delays and eventually impose limits on communication. There's a 3-second delay in radio signals between the Earth and the Moon, and a roughly 15-minute delay between Earth and Mars. There would be more than a 4-year delay between Alpha Centauri and Earth, which is great enough we couldn't reasonably work with it. If something happened to the people out there, they'd be on their own. Also, for reference, in all my saddle time on a real motorcycle, I was never this reckless to bounce off rocks like that. I'm gonna take a shortcut through that field, and get eyes on this hill, or get eyes from the hill on the next point of interest down there.
Got another tango. Baby makes 3.
Look, more bad guys. Let's go blast us some poor, unsuspecting, casual drug dealers. The next problem with travel and operation at these great speeds and distances is known as time dilation. It's the difference in elapsed time between us here on Earth and the amount of time that would have elapsed for whatever or whoever is traveling at near the speed of light. I'll continue using my 25% of light speed crew on a trip to Alpha Centauri for this example as well. Oh crap, there's more bad guys up here. I'm glad they're stupid and didn't see me. I was too busy talking and got distracted.
Got a third.
Stuff like that could easily be game over for my agent here.
Roger that.
And I'll call on my NPC friends for help again.
Roger.
Boom.
Target acquired. Opening fire.
He's down.
Okay, now I'm gonna go sneak closer and take out this guy and put some explosives on their vehicles. Like I said, causing mayhem for the cartels. And boom. Because the crew of the aforementioned colony ship would be traveling at 25% of the speed of light, their perception of time will be slower. Their view of Earth, or from the view of Earth, their trip will take 17.8 years. Or 17.48 years. However, this perspective from the crew of the ship, it'll take 16.92 years. And the colonists will have 6 months of their lives saved during the trip because time dilation. This will also have a perceived difference in travel. Distance travel. The actual distance is 4.37 light years, but because of the speed, the perceived distance traveled would be 4.23 light years. Sure, 4.23 doesn't sound like much compared to 4.37, and skadoosh, there we go. But, sorry, back to the topic at hand. But there is a difference, and more to the point, it's 1.4 trillion miles. For example, this example is only for a trip to the nearest star system. Traveling to other stars, traveling greater distances and longer times will only amplify this time dilation effect. If we travel to one of the solar systems that is important to the events of my book, which for the sake of spoilers will go unnamed, I'm only using it because I know the distance off the top of my head. The perceived travel time at 1/4 light speed is 5,422 years, yet the actual travel time is 5,600 years. And even though the actual distance is 1,400 light years, the perceived distance would be measured as 1,355 light years. I'd also like to note and calculate all this time dilation stuff. I use this website calculator thing, and I'll leave a link here in the description.
I got a Sicario.
I don't want to go back through the town. There's too many bad guys. They might already be on alert from those explosions. I'm going to see if I can get out a different way. play in the water again. I can even provide real-world examples of time dilation. The person who holds the record for the most time gained by space travel is a Russian by the name of Sergei Krikalev. I apologize for my butchering of the pronunciation. It's not intentional. He made 6 total flights, 803 days, actually, in space. Oh man, the water was too deep. Ruined my motorcycle. I gotta find another set of wheels. Alright, gonna cross the water, through the bushes. It'll be all cold now. Oh, look at this guy. He's one of the rebels that I'm helping fight the cartel. I'm sure he won't mind if I take one of his cars here. But really, who parks cars like that? How am I supposed to get into it? Nope, can't get in that way. Alright, I'm gonna go through the passenger side, because that's the thing we can do. Alright, comrades, load up. Anyway, back to Sergei's story. It's an interesting one, and I'll try and be brief so I don't get too far off track. But, long story short, he was aboard the Soviet space station Mir in the early 90s when the Soviet Union collapsed. Because of the economical and political turmoil in Russia during this period, he was stuck in space. There was no one to come get him. He had no home to go to. The Barkanau Cosmodrome that he was supposed to land at was now located in Kazakhstan, which was no longer part of the Union. There were all kinds of questions of citizenship and such. And it was an awful mess. He took off as a Soviet citizen and landed as a citizen of the Russian Federation. He was stranded on the... Oh, crap. See, this is why I prefer bikes instead of cages with 4 wheels. A significant portion of them handle like crap. I had to stop to save it from the oversteer. Anyway, back to the story. Sergei was on the Mir space station for 311 days, departing in July of 1991 and landing back on Earth in March of 1992, often called, quote, the last Soviet citizen, because of the high orbital velocities he was traveling at for the entire time aboard the Mir space station. He, to a lesser extent, experienced time dilation. It would be impossible or imperceptible to a human, but mathematically speaking, over his career in spaceflight, he has saved 0.02 seconds. I know, 200ths of a second is nothing in the human lifespan, but this is measurable, literal time travel. It would have been more, but because the Mir space station orbited at 17,200 miles per hour instead of a greater fraction of speed of light, that's all he could get. Still, that's crazy, isn't it? He's an actual time traveler. It's made even more crazy because he was actually stuck in space. I'm just going to stick a tracker in this random crate of supplies on the side of the road. And look at the map again. I don't think I'm going to keep driving that van. I'm going to swim across the river from here. I'm going to try and steal a better vehicle from the bad guys on the other side of the river. Check for traffic, because getting run over sucks, and that would be game over. Alright, the other problem with FTL is what happens when you actually reach or exceed the speed of light. Do things continue to function normally? Does the sky go dark until you slow down again? No one knows. We don't really have any way of knowing what would actually happen when you exceed the immeasurable. We have no way of knowing and no way to measure or calculate because it's beyond the limits of instrumentation, the ability to measure and observe. And even then, after you reach the speed of light, how do you slow down again? Is it possible to become... or it's possible that some shorter trips could take longer than longer trips, because you need the space to decelerate, and you might not be able to reach top speed before you have to start slowing down again. To tackle a slightly more complex area of the topic, or at least mathematically complex that is, let me mention propulsion systems and exhaust velocity. Oh look, we're bad guys. Rifle. And... come on. Don't move the mouse too much. There we go, headshot. See if anyone else is around. And
Sniper on that
headshot.
roof.
Maybe. There we go. Had to be sure. Oh look, more bad guys.
That tango might spot you.
Boom. And one over there.
Marked. It's a little
Catch.
close to civilians.
Ignoring what I mentioned earlier about fuel and fuel consumption and fuel weight creating a vicious cycle. If you have a magic source of power that doesn't add weight or otherwise cause problems for your spaceship, you still have two very big problems to face with your propulsion system. Firstly, exhaust velocity. In order for the vessel being propelled by the engines to reach the speed of light, the speed at which the engine does work must slightly exceed the speed of light in order to achieve it. Equal and opposite forces and all that important physics stuff, right? On top of being difficult to do that, making light speed propellants, the other problem comes to impulse. Not just maximum speed, but the speed that the engine can accelerate the vessel is also a problem. Yeah, I'm gonna sneak down this road behind this building. I'm gonna go parallel to the road. See what else is around there. Nobody over here. Alright. Hey. Alright. Now that truck. I'm gonna borrow that white one. As I was saying, it's great that your engine is 110% of light speed. But if its efficiency and impulse are low enough that it takes the vessel 500 years at constant acceleration to reach light speed, then the point is moot for all but the longest trips. And this problem works in the opposite direction too. You'd still have to decelerate, and if it takes that long to slow down, oh well. Speaking of problems, I'm going to sweep this building, make sure there's no bad guys inside. Nobody on the ground floor. Up the stairs. Sneaky, sneaky. I'm gonna mess with their radios. There's nobody on the roof. Let's check the second floor. Nope, second floor is empty too. Alright, time to get out. Now where was I? Problems because... Oh yeah, because electronics. And to an even greater extent, the human body can only withstand so many g-forces. You accelerate too quickly and we may well kill the people we're trying to transport. And that doesn't do them much good if they never make it to the colony they're supposed to reach, right? Or maybe everything stops working entirely once you pass the speed of light. Do you simply wink out of existence, go into some other plane? Will you be frozen in time forever, unable to move to shut down the engines, doomed to accelerate endlessly? Will computers even still work after your rate of travel exceeds the speed of light at which signals are moving inside their CPU? No one knows. There's no way to tell until we get there. Come on. Get in the truck, you silly NPC. Let's go. Thank you. Time to bounce. Let's get out of here before the bad guys catch on that I'm stealing their truck, because I know there's more in the area. See, like those guys. Let's get out of here. I'm going to take a shortcut across this train bridge. Anyway. So there's a few of the major practical problems facing galactic speed limit. One problem humanity has yet to discover a good solution for. I'm sure I could come up with more problems if I sat down and thought about it longer, or started talking in depth about the effects of long-term life in zero gravity on the human body. These kinds of problems are often neglected, overlooked, and unanswered by science fiction and sci-fi authors. I feel it's just glossed over because it's difficult or inconvenient. And there's going to be another point of interest. See the question mark? There's another interesting spot down here. Let's see what's downhill. Plus, there's always more to the problem to discuss than what I was already talking about. These are just basic concepts, conceptual problems. Like, physics and interstellar navigation and life extension and so on. I'm only going to try and hold your attention for so long. Yeah, there's a helicopter down here. Alright, that is a little interesting. Anyway, at least to me, this doesn't feel like much of an explanation, but I can't really go into any advanced mathematics in this format without a whiteboard or something. I hope I piqued your curiosity, and feel free to look into the problems on your own. Oh, it's another rebel hideout. This sounds like a good spot to take a break. I'll cut it off here so this doesn't get too long. If you're still here, thanks for watching and listening as I scratch the surface on Faster Than Light Travel. Bye now.